I've already mentioned that. So we have two types of tubes. One of them is open, and the other one is open closed, or you can just close. You can just call it a closed tube. So open tubes are the similar are actually the same as the strings. You know, like the pattern you see are the same. Is the same. So if this is point A and point B, and you're blowing air through this, like you're making sounds, okay? The first possibility is like this. The second one is basically like this. The third one is like this, or so, yeah. The third one is like this. So you see we have seen the same pattern in the in a string, right? And so we can safely say that the harmonic, the formula for harmonic, the wavelength of each harmonic is lambda n is equals to 2L by n, and that's true for string, and remember this, and open tubes, or open tubes, right? That's it. And that's the mistake people, like I've checked a lot of papers, I've seen a lot of students doing a similar mistake. Like they use this formula for closed tube. The closed tubes look like this, right? So you can't use it, and here's the reason why. So we have done a lot of experiments in the past, and we have noticed, like in a closed tube, the two ends either have two different points. One is antinode, the other one has, if one end has an antinode, the other one has a node, or vice versa. So like if one end, let's say this is the opening, the opening end has a node, the other one must have an antinode. That's a fact. That's something you have to remember, okay? Because there is nothing else. There is no this is closed. So the air reflects. It's on the air. The wave reflects back to the same position. To the same position, right? So, and this is basically the first possible outcome you can find in a closed tube. Okay, so this is the first harmonic, and what if you want to plot this graph in a like the wave in this graph, well, what should it look like? This is basically this, right? Can you see it? I guess you can, right? Yeah. So if I draw a full wave, right? If I draw a full wave, how much is it? This is 90 degree of a sine wave, right? So what is 90 degree? 90 degree is okay. So if the tube is L, and so what is the wavelength of this tube? What is the wavelength of the wave produced in this tube? This is basically 1/4 of a wavelength, right? Like 90 degree divided by 360 is your wavelength, right? And this is equals to L. So what is L? So 90 by 360 is basically 1/4. So what is L? L is what is lambda? That's 4L, right? So you're taking four tubes, like you're taking 4 tubes and connecting them to one end to the other, and then you're getting one complete wave. That's how you have to see this. All right. So this is the first harmonic. So what should the second harmonic look like? Here you will see a changing pattern. That's the thing. we have established first, so lambda 1 has 4L. So what should be the lambda 2? Since I've said if one end has a node, the other one should have an antinode. So if this is like this, then this is how the second one looks like, right? The second second harmonic. And and if you draw a graph, of wavelength of this wave, what does it look like? It looks like this and this up to till this part, right? So we are missing this part is missing. And what is it like? This is 270. So basically you have a wave of 180 plus 90 of 270 degree inside this tube L. So 270 by 360 is basically 3 by 4 lambda, right? So lambda. So 3 by 4 lambda is L. So lambda is 4 by 3L. So we can safely say the second harmonic is 4 by 3L. But here if I wanna go to the other one, the third harmonic, because I've done the same for the string. Let's do it for the third one, and here you'll see something different. It starts like this and starts like this, comes back, ends here, and then like this, something like this. I'm sorry for the bad drawing. I'm really bad at this. I've explained it before. I've said this before, and I'm saying this again. Like, I'm extremely sorry. This is how it should look like. I hope you can see this. So what is this? How does this wave look like in a graph? This looks like this and this additional part, right? Node and antinode. This is how it looks like. And if this is 360 degree, and this should be 90 degrees, so 90 plus 360 is, how much is it? It's basically 450 degree, right? 450 degree. So what is 450 degree divided by 360 lambda? So 450 divided by 360 is 5 by 4 lambda. So we are getting 5 by 4 lambda here. So inside this L tube, we are seeing the third harmonic looks like this. 5 by 4 lambda is L, right? So what is the lambda? The lambda here is 4 by 5 into L. So third harmonic is 4 by 5 into L. But that's the thing. I can see a pattern. I can see a pattern here. I can see some sort of pattern here. Like, let's write this down. Let's write this down here. L1, lambda 1 was 4L. Lambda 2 is 4 by 3L. Lambda 3 is 4 by 5L. If you notice, here's a 1, here's a 3, here's a 5. So I can see a difference of 2 in each of this in, in each of this sequence, right? So and that's where the idea comes from. So the first harmonic is actually called first harmonic because n is 1, but the second harmonic is actually not the second because, well, we can see that it's increasing by 2, like in each, like every harmonic is the number of term, the n is increasing by 2. So I'm noticing odd numbers here. I'm noticing 1, 3, 5. So the integer values, the integer n is always odd number. So 1, 3, 5 dot 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 towards infinity of odd numbers. That's it. So lambda 2 is basically lambda 3, third harmonic, and lambda 3 is basically 5, fifth harmonic. So in a closed tube, we don't really have the even harmonics. We only have the odd ones. So if this is n, lambda n, what is the formula? The formula is 4L by n, right? Considering n is odd numbers, is odd integers. Yeah, that's a better phrase. Odd integer. This is string. This is for this formula is for string and also open. Not this one. Where is my red pen? Yes, here you go. Open tubes. We have the same formula. For closed tubes, we have lambda n equals to 4L by n, considering n is odd integers. So remember, we do not have even harmonics in a closed tube. We only have odd harmonics. 1, 3, 5, 7, 9. That's it. That's what you must remember.